Hey everybody, today I'm going to talk about acids and base theories. These two are the ones that you're responsible for in my class. They're also the two most common acid-base theories. So there's two main theories of acids and bases, the Arrhenius definition and the Bronsted-Lowry definition. In the Arrhenius definition, acids donate an H plus ion when dissolved in solution. You can see this here illustrated by the HCl plus H2O gives you H3O plus and Cl minus, because in this equation the HCl is the acid. It donated the H plus that it had, leaving the Cl minus and changing water to H3O plus. In the Arrhenius definition, bases donate an OH minus ion when dissolved in solution. So NaOH plus H2O gives you Na plus OH minus and H2O. In this equation, NaOH is a base because it donates the OH minus. This is the pretty standard definition of acids and bases that we see a lot. So for the acid, if it's like HCl, when it dissociates or breaks up in water, since it's donating an H plus, that's an acid. Meanwhile, bases, when they dissociate and break up in solution, it donates an OH minus. Okay, so the OH minus makes it a base, and the H plus makes this guy an acid. Okay, the next definition is the Bronsted-Lowry definition. It's a little different. Now, the acid part is actually exactly the same. The acid says exactly the same thing. An acid was anything that donates an H plus when dissolved in solution. Same as the definition as the Arrhenius theory. But in the Bronsted-Lowry definition, one of the major differences is that bases accept an H plus ion when dissolved in solution. This means they don't always have an OH minus group. For example, ammonia, which is one of the most common bases, NH3, has no OH group, so it doesn't match the Arrhenius definition. But it can still accept an H plus ion and form NH4 positive. Okay, so it's accepting the H plus ion, which means it is a base. Now, it's important to realize that with the Bronsted-Lowry definition, you're going to have what we call conjugate acids and bases. Conjugate acids and bases are when you have on one side of the equation an acid and a base. Okay, but after that acid donates a proton, it becomes a conjugate base, because once it's lost a proton, then it wants to receive a proton back. Acids and bases a lot of times will flux back and forth. This is called equilibrium, and because of this, we have these conjugate acids and bases. They change from one to another back and forth sometimes. Like, for example, here you've got NH3, which is your base, and in this case, water is going to act as an acid. Remember, water is equal parts H and OH, so water can be either an acid or a base depending on who it's mixed with. So in this case, water is the acid, and NH3 is the base. NH3 wants to accept an H plus ion, so acid will donate that H plus ion over to NH3. Once that happens, the NH3 becomes the conjugate acid, because on the other side, it's gained the H plus. Now, if you look at this by itself, it is willing to donate an H plus, so it's an acid. Whereas the water lost the H plus and is now OH minus. It's what we call the conjugate base. So the acid becomes the conjugate base, the base becomes the conjugate acid. On the sheet down here, we've got a couple practice equations. I did some of these in my class, but if you're in my class or you missed that, I'm going to do a couple other ones here. So let's do number 2. Number 2 says, if I have OH minus plus HCN, this will result in H2O and Cn minus over here. Oops, I wrote a plus. That should be OH minus. Alright, so that is our equation. Now we have to identify the acid, the base, the conjugate acid, and the conjugate base. So the way I approach these problems is I always just look at one side first. I always just look at the left side. And I'm going to look at the reactants, and I'm going to decide which one of those is an acid. Remember, acids generally start with an H. Also, this OH minus should scream base to you, because OH minus is usually a base. It also has a negative charge, which means it wants to accept a positive. So, based on this, I'm going to say this is my acid, because the H in the front and the OH minus is definitely going to be my base. Okay? So the acid and the base always act the same. The acid donates the H+, the base accepts the H+. So this acid is going to donate its H+ to the base. Okay? So if HCN loses the H+, that means the only thing left will be Cn with a negative charge. So this becomes this guy right here, which means the acid switches and becomes the conjugate base. So this is my conjugate base right there, leaving me with only one conclusion, that this base right here, once he accepts the H+, he becomes H2O. So H2O on the right side is my conjugate acid. Hopefully that makes sense. Let's do a couple more just to make sure you got it. Let's do number 3. Okay? So number 3 says HCO3 minus plus an OH minus results in H2O and CO2. Alright, so once again, just look at the left side. I want to look at my two reactants. I got to decide which one's the acid and which one's the base. Now, out of these two, which one is more likely to donate an H+? They're both actually negative, so both of them really technically want to gain an H+, but in this case, one's got to be the acid, one's got to be the base. This has an H in front. Okay, it's probably got more likely to donate the H+. Also, OH minus, once again, should scream to you that it is a base. So this guy is definitely my base. OH minus pretty much always acts as the base. And this has the H to donate, so that is going to be my acid. Okay? Remember, the acids always donate an H+, so the acid is going to donate an H+ to the base. Okay? So, the base is going to gain an H+, meaning it's going to become H2O. So H2O here is my conjugate acid, which means CO2 is going to be, CO2, that's wrong, CO3 minus 2, oopsie. That means CO3 minus 2 is going to be my conjugate base, because once HCO3 minus donates that H+, it will change into CO3 negative 2. Okay? Let's do one that's not on the paper. So using this, you should be able to easily predict what the conjugate acid and conjugate base are going to be. For example, if I have, let's say HBr plus H2O, and I don't know what that's going to create. But I do know which one of these is an acid, which one's a base. Remember, water can be either an acid or a base, whereas HBr has got that H in front, telling me that he is an acid. Water, if it's with an acid, water is going to act as the base. So in this case, once again, they always behave the same. The acid is going to donate the H+ to the base. And once he donates that H+ to the base, he's going to lose that H+. Meaning, this acid goes from HBr to Br minus. So the acid switches and becomes my conjugate base. Meanwhile, the H2O is going to gain an H+, which means he's going to be H3O+. And over on that side, the H3O plus is my conjugate acid. Okay? So this is how you can tell conjugate acids and bases. If you need more help, talk to me in class. Thanks, guys. Have a good night.